Hi everyone, let's talk about some of the topics that I think you should focus on when studying for this mid-semester exam. We're going to go through a bunch of things, some of them sort of general, some of them fairly specific, and we're going to do a couple of calculations as well, but very simple sort of stuff generally. Okay, so let's look at this first page. Economic models and assumptions. We need to understand the role of assumptions when it comes to economic models. A model is designed to somehow represent reality. So it'll never be as detailed as reality due to data constraints or cost issues or whatever the case may be. So assumptions have to be made. Assumptions are educated guesses. We have to have faith in our assumptions. So there's 3 points there that I want you to look at. Models use assumptions when there are gaps in the data. Therefore, they are not detailed representations that include all aspects of an environmental issue. And this is the key one. The accuracy of the assumptions is critical if we are to rely on the output of a model. So assumptions are inevitable. The accuracy of the assumptions is important. Okay, let's move on. Some issues with cost-benefit analyses. So cost-benefit analysis. A recap, we measure the benefits of doing a particular thing, we measure the costs of doing that thing, we subtract the costs from the benefits, and assuming it's a positive net result, we might go ahead and do that project. Great. So even though that may be the case, there are some downfalls, and I've got 3 big ones here. There may be a timing mismatch between the benefits received and the costs incurred. Projects are often multi-year sort of deals. So the benefits may not accrue until, say, year 19, but there may be costs incurred in those 19 years, for example. So that's a timing mismatch. A second issue, the beneficiaries of the project may not be the same people that incur the cost. So whilst the benefit may outweigh the cost, the people who get the benefit may not be the same people who incur the cost. And finally, there are limitations to how we are able to value certain benefits and costs. Limitations. So if something's in a market, we can value it, but if it's not, we have to rely on non-market valuation. We might look at surveys. We have a raft of things that we can do to try to value non-market things. Okay, so just some very short notes on issues with cost-benefit analyses. Finally, on this page, let's talk about the difference between positive and normative economics. Positive and normative. You could also describe these as being objective versus subjective. Or you could describe it as being what is or could be versus what should be. If I make a positive economic statement, I'm just relaying facts. If I'm making a normative economic statement, I'm making some sort of a value judgment. So positive is what is or could be. Normative is what should be. A pretty clear distinction. Just make sure you know the difference between the two. What's next? Okay. Use value, non-use value, etc., etc. You can find information on this in your text on page 22. Otherwise, here's a nice little decision tree or flowchart from lecture 1, I believe it is. So make sure you understand the types of values. Let's look at broadly the two types being use versus non-use. So over here we have use, which breaks down like this. Direct use. This is my neighbour who goes and walks through the forest at the end of my street. Indirect use. This is me who doesn't bother going walking, but the birds in my yard breed and live in the forest at the end of the street. The closer we get to non-use, the more non-use it is like. So let's look at option use. Nothing's happening, but you have the option for something, some sort of a use there. And that has value in itself. And then right over near non-use, we have bequest value. So if you bequeath something to someone, that's you giving them something. It's often referred to only when someone passes away and you put it in your will, for example. So there's, despite not having a use, there is value that may be bequeathed to someone else. So let's go over to non-use value, and there's also a bequest value there as well. Existing value. There's a rainforest on the other side of a hill nearby, and I've never been there, I will never go there, I can't see it, but you know what? I like that it exists. I like that. So it has some sort of value to me. Have a read about this sort of stuff on page 22. Don't get into it in too much more depth than what we've just spoken about. Okay, what's up next? Let's talk about static efficiency versus dynamic efficiency. Static versus dynamic. You can read about this in page 61 of your textbook. Otherwise, let's just go over the differences here. So, if we have some natural resource of which there is a limited stock, I can ask myself, what's the socially efficient quantity to use this year? Right here and right now. And I can make some calculations and find that out. Then next year I ask myself the same question, and the year after that. Well, that's static efficiency. That's thinking of the here and now only. Sustainability, however, inherent in sustainability, is this idea of considering future generations or future periods of time. And that's what dynamic efficiency is. Finding those quantities of natural resources to use now and next year and the year after and so on and so forth that will maximise our social net benefit. That's the idea. So the simple answer here is static efficiency is only caring about the here and now, whereas dynamic efficiency is adjusting how we think and therefore calculate quantities based on what future generations may need as well. There is another name for dynamic efficiency, and that is intertemporal. Temporal means time, inter means over or across or something like that. So intertemporal efficiency is the same as dynamic, and it means efficiency over time. What do we have now? Okay, could you tell the difference between a public and a private good? Could you do that? If you can't, you probably should. You can read about it on pages 40 and 41. Otherwise, let's have a quick look at this sort of thing. So I have 4 types of goods here, and the 2 I want to focus on are this one, public goods, and this one here, private goods. What type of good a thing is determined by 2 questions: whether it is rival and whether it's excludable. Let's talk about rival first. Something is rival if consumption by one person somehow affects the consumption of other people. It's rival if the consumption of one person somehow affects the consumption of other people. Excludable. Something's excludable if you can literally exclude people from that particular good. So they're the 2 questions. Is something a public good? Well, I ask myself, is it rival or not? If it's non-rival and it's not excludable, it's a public good. Is something a private good? And I ask the same 2 questions here. The importance of categorising these goods is that humans behave differently depending on the type of good that it is. And you can probably understand that. If a good is non-rival, well, that means that everyone can go and partake in that, take that good or partake in whatever that good gives you. Right? Everyone can go and do it. So that will affect behaviour. In addition, if something is non-excludable and no one can be excluded from doing it, people will flock there and do it. So humans behave in certain ways depending on what type of good it is. You can see the classic examples here. Private goods. Ice cream. Is this rival? Well, it is. The more ice cream I have, the less you have. Is it excludable? Well, it is, because you can exclude who gets the ice cream. So that's a perfect example of a private good. A public good? Fresh air. Defence. These are perfect examples. Fresh air is non-rival. I can breathe as much as I want, and so can you. And it's not excludable. No one can exclude you from breathing the fresh air. So, quick rundown, difference between public and private goods. Get comfortable with asking these 2 questions, and if you were given a list of particular goods, could you determine which are public? Okay, Willingness to pay. Could you recognise willingness to pay on a graph? What is willingness to pay? Well, it is the maximum amount someone is willing to pay for a good or service. But it's also the marginal benefit curve. And it's also the demand curve. So if we've got this graph here with a quantity here and a price up here, a supply curve here and a downward sloping curve here, we know that that's the demand curve, it's the marginal benefit curve, and it's also the willingness to pay curve. So just understand where to find it on a graph, understand what it represents, understand that it represents the maximum amount someone is willing to pay for a good or service. Represented here, we have a quantity of a good or service and the maximum amount someone's willing to pay based on this willingness to pay curve. On this topic of willingness to pay, let's take a look at this table. We have three columns, a quantity column, a marginal willingness to pay column, and a marginal cost of production column. We're producing widgets, we're told. What we're being asked to do is figure out the socially efficient output level and the net social benefits at that output level. So let's figure this one out first. The socially efficient output. So output's going to be here in the quantity column. Just take note of something. Willingness to pay, this is a demand schedule. It would be graphed as a demand curve. Marginal cost of producing, or marginal cost is the same as the supply curve. So what we have here is a demand schedule and a supply schedule. Let's figure out this socially efficient output level. The quantity I will produce at is 5. And that's because I want to produce at an efficient level, which is always where marginal benefit equals marginal cost. And that's all these two columns are, a marginal benefit curve and a marginal cost curve. So usually on a graph we look for where they intersect, that equilibrium, but on a table we have to look for where the numbers are the same. Now I've chosen 5 as the quantity we stop production at because after 5, marginal benefit is less than marginal cost. And we don't want that. So we wouldn't produce 6, we'd produce 5. That's the last quantity or the highest quantity when marginal benefit exceeds marginal cost. So the answer to what is the socially efficient output level is 5. That's what we have here. Now let's figure out the net social benefits at that quantity. We do it like this. Total benefits minus total costs, but only up until that quantity. So we would add 180 and 170, 160, 150, 140, which gives us 800. We'd subtract from 800 the sum of 0, 30, 60, 90 and 120, I should say, which comes to 300. So total benefits minus total cost give us the net benefit of 500. Get familiar with this table and what we've just gone through. If you were to get something like that in the mid-semester, be confident in being able to answer similar questions.